Today we're going to learn about the cylindrical shell method and how you can find the volume of an area when it's rotated around an axis. So take for example this area right here and pretend you're trying to rotate it around the vertical y-axis. If you were to rotate that area around the y-axis, you'd get a 3D shape that would look kind of like this cake pan. So if you're trying to find the volume inside of the cake pan, you could use little shells or cylinders and stack them inside of it and find their surface area to find the volume. If you're trying to find the surface area of the cylinder, you can use the formula 2 pi RH, where h is the height and r is the radius. So if you look at the shape you have, you can draw a line parallel to the axis of rotation and call that the height. You can then know that the distance from the axis of rotation to the height is the radius. That makes a cylinder, and you can see that because it curls around the axis of rotation and then fits inside of your volume, and it will stack upon each other to fill the whole volume. That is why the shell method has the formula of the integral from a to b 2 pi RH, which is the surface area of the cylinder.
For example, we have here the graph of f of x and g of x in the first quadrant, their intersection points being at x equals a and x equals b. And in this problem, it's asking us to rotate the area of this region around the y-axis. And in order to do that and find the volume, you would first need to draw in the height, which is just the distance in between f of x and g of x. From there, you would draw the radius, starting from the top of the height to the axis of rotation, which would be the y-axis, and that would be r. Since r is just the horizontal distance from the axis of rotation, which is just the y-axis, to the graph, r would equal x. And since h is the distance in between f of x and g of x, we would say that h is equal to f of x minus g of x. A unique thing about the shell method that makes it different from other methods of finding volumes is that when you integrate with respect to the opposite variable of the axis that you're rotating it around. For this problem, since you're rotating it around the y-axis, you would integrate with respect to x. So your answer ends up being 2 pi, since you can pull out the constant, of the integral from a to b, which is your parameters, your intersection points with respect to x, times the radius, which is x, times the height, which is f of x minus g of x dx. So for this problem, we're going to be using this graph, which is the equation x equals 12 times y squared minus y cubed. And we're going to be rotating it around the x-axis to find the volume of the solid that would be formed.
Why can't you use the washer method?
In this scenario, there are two reasons why you can't use the washer method. The first is that the washer method, when rotated around the x-axis, would require you to integrate with respect to x, which would mean you would have to solve this equation for y, which would be impossible. The second reason is that when you do the wash method, you have big R squared minus little r squared. And in this case, since the curve is the same curve with the same equation, it would be this minus this, which would equal 0. And so therefore it wouldn't work. Okay, so when you're solving this problem, when you're rotating around the x-axis, the first thing that you would do is draw in your height. And since you're integrating with respect to y, your height would be from the y-axis to the end of the curve. Which ends up being x, which is equal to 12 times y squared minus y cubed. And then your r would just be from the top of this down perpendicular to the axis of rotation, which ends up just being y. So then, since you're integrating with respect to y, you're integrating from 0 to 1 times 2 pi, the constant, of the radius, y, times the height, 12, times y squared minus y cubed dy, which when you plug it into your calculator, you get 3.78.
Alright, so this time we have the exact same formula, which is x equals 12 y squared minus y cubed, but this time we're going to rotate around the line y equals 1. So since that line is a horizontal line, you're still going to be solving with respect to y, which means your parameters are still 0 to 1. The first thing you're going to do again is draw your height, which is parallel to the axis of rotation. And that height is just x, which in this case is 12 y squared minus y cubed. The next thing you're going to do is drawing your radius, which goes from your height to your axis of rotation. In this case, this whole distance here is 1, and this distance right here is just y. So your radius is going to be 1 minus y. So if you put that all together, you have 2 pi times the integral of 0 to 1 of 12 y squared minus y cubed times 1 minus y dy. And that equals 2.51 if you enter that into your calculator. Okay, we're going to do one final problem with this formula, x equals 12 y squared minus y cubed. But this time, we're going to have the axis of rotation equal to negative 2/5, which is below the shape that we're rotating around. So, same thing, you have the height, which is just x, which is 12 y squared minus y cubed. Now, you bring the radius down to the axis of rotation, so you have y and 2/5. So this time your radius is just y plus 2/5. And if you put it all together, you have 2 pi with the integral 0 to 1 of 12 y squared minus y cubed times y plus 2/5 dy, and that equals 6.28. And that's all for the cylindrical shell method.